Hello everyone. In today's class, let us start the discussion about next concept of Newton's laws of motion. So we have given introduction for momentum in the last class, but we need to know about completely what is momentum, what is change in momentum, what numericals based on this concept will be come in the paper or exams. Let will solve some models. Next after that impulse. Okay, what is impulse called and what is the definition and what are the numericals based on it we will look after. And last one, conservation of linear momentum. So let us start discussion about momentum first. So momentum is actually called generally product of mass into velocity, generally basic definition. Okay, but actually here what we can discuss, quantity possessed by the object by virtue of its mass and motion. That is mass and motion. Motion explains velocity, mass explains m. Okay, so nothing but here generally mass into velocity we can roughly take the one idea. Otherwise, this is very important theoretical definition it is. It is also called quantity of motion. Okay, so momentum is also defined as quantity of motion. So generally, when a friend seen, for suppose you are a group of friends, okay, na, one friend seen some situation like a small car going with high speed on the road, okay, and he was explaining to you like I have seen some car, it is going with a greater speed, means he was explaining nothing but the quantity of motion of that particular object. Okay, so it's having less mass. Suppose he was seen some situation like a heavy good truck going with a greater speed, suppose. Okay, na, same scenario, he was explaining same kind of situation. I saw like a truck is going on the road which is having very heavier mass even though it is going very fast. So like here the coming quantity which is to be understand is nothing but momentum. And generally this momentum especially we need to call linear momentum. Okay, na. So yesterday also I told you in the last class also I told you it is linear momentum. Okay, so why should we call linear momentum means in the coming chapters one more quantity will come, angular momentum. Okay, na. So we need to have an idea about linear momentum, means we are use this as linear and it is explains for the motion of a body which is moving along straight line. Okay, so once again it is the quantity possessed by the object by virtue of its mass and motion is called linear momentum. Next, it is also defined as quantity of motion. Okay, na? And generally it is indicated with the P letter and P equals to mv. So generally we can call P equals to mv is the momentum equation, and where velocity is being vector, so linear momentum also vector quantity. So that is, it is a vector quantity. Okay, and its units are like kg meter per second. Okay, na. So now let us see P equals to m into v, and here units need to be derived, na. So how can we derive? Mass is measured in terms of kg and velocity can be measured in terms of meter per second. So the same unit you got whatever we have written here. Okay, kg meter per second. And one more point also we can write. So small other terms, right? 1 Newton equals to, in the last class, like giving the description of the force, we have taken units for the force as Newton, and I gave Newton equal to 1 kg meter per second square. Let us suppose to be take here unit can be taken as kg meter per second square. Okay, so let me take here second square, 1 second to be shifted left side, that is Newton second is equals to kg meter per second. So kg meter per second is the unit of what? Momentum. So which means Newton second is also unit of momentum, because these are equivalent. When these are equivalent, they can be given in the terms of what? Newton second. Okay, na? And here cautious notice also we can take. Generally, in the usage of the units of the physical quantities, many students have a habitude to write, suppose if sir dictate a question, 10 newtons of force acting on the body. Okay, you are expressing this is in plural. Okay, na? According to you. But actually, according to physics, we don't write ns because you are expressing force in your words, but it comes a momentum unit. Okay, na? In the question, if sir dictates, suppose if a 10 newton of force acting on the body, like 10 newtons of force acting on the body, while you write in the notes, na, 10 newtons means 10 n only you should write. Don't write 10 ns. Okay, na? Why? Because the physical quantity only completely change. Ns is the unit of what? Newton second, unit for momentum. So you are writing momentum as sir is explaining about force. So this kind of misconcepts will be there while you are expressing the units for a particular physical quantity. You just remember that. Don't make them plural. Okay, na? Just remember this one, right? Next, being it is a vector, definitely its direction must to be indicated here because both magnitude and direction must to be there. So here it is explained that it is positive x-axis, it is positive y-axis, and if it is going in left side, okay, na, negative. So here one situation we have seen, that is one object is going right side, so along positive x-axis. So that's what it is expressed with p equals to plus mv1. Okay, na? And next, if the same body going along negative x-axis, its momentum is given as minus mv1, right? Sir, why we should take it is minus? Because it is a vector first. Second, its direction to be represented. Okay, na? And first one we have taken plus. So opposite to first direction is taken as minus. These are the reasons why we need to indicate this is as minus. Next, if you take this is as plus, suppose left side particle moving as taken positive, then right side moving particle should be taken as, means momentum of right side moving particle should be taken as positive, sorry, negative. Okay, so here the sign convention will be depends on you. You can take in any direction is positive, for that opposite direction you should take it as negative. So clearly once again, if you choose right side is negative, suppose, then left side you must to be take as positive. Then their symbols will be exchanged. Okay, na? But you should aware about the sign convention, what you have taken. Okay, na? Depending on that, final answer comes with plus or minus. So that explains you in which direction actually the quantity involved to change. Okay, na? This is an additional part where we can mostly use the sign convention in the numericals. Okay, sir, we don't remember this kind of data, so we just follow blindly coordinate system. Then definitely you can follow. Right side you take plus, left side you take minus, up side you take plus, down side you take minus. This is what I have explained already. Okay, na? It is somehow additional part I told you. If you can remember and if you can able to apply multiple directions, okay, na? Means according to your own system. Okay, sometimes left side only given as positive in the question. If change is given in the question, then you can follow this situation. Okay, na? Next, change in momentum in different cases. What kind of change in momentum will be takes place in different scenarios? Let us see here first, very important point here. Here we can solve some conceptual plus, which is very important to solve the numericals. Where a ball is moving right side, ball of mass m, right side it is moving. So it is actually having momentum. Momentum is nothing but mass into velocity. So now change in momentum I need to explain first. So change in momentum I am taking as delta p equals to p final minus p initial. Final momentum minus initial momentum, that is change in momentum. So ball is going right side with a speed u, and suppose it is got stuck or just it is got a rebound from the wall. Then what is the change in momentum? Depends on rebouncing conditions. Okay na. Suppose if it is going to be rebound with a speed u only, suppose it is rebound from the wall with a speed u, then you should understand change in momentum. How do we apply? Let us see here. First of all, left side is final momentum actually. So here this is I am taking minus mu, and initial momentum p initial mu. Okay, right side. So right side I took positive, left side I took negative. Then according to change in momentum formula, we just indicate delta p equals to p final minus p initial. As per the symbol we write minus mu minus here plus mu. So finally minus 2 mu. Okay, so this is a delta p. So answer came minus. Answer came minus means change in momentum also vector. So its magnitude is 2 mu. Minus indicates that change in momentum directed away from the wall. Okay na? Change in momentum directed in which direction? Away from the wall, right? So that is what indicates here minus in the answer. Okay, so now let us see one more case, that is okay, here it is the ball and it is going to strike and it is moving with a speed u suppose, and it rebounds with the same speed suppose. Okay, and here two conditions will be there: angle with normal, angle with wall. And if I suppose to take angle with the normal theta and with the same angle it rebounds, okay na, then we can just take as components of the velocity. Then actually mass of the ball is m, so mass into velocity taken as momentum. Change in momentum we need to find out. Okay, so how do we find? Let us see here. Just we can find the example here just to see. First components we will take. This is u and here it is theta, then this become u cos theta and this become u sin theta. Okay, and at the same point here also. Okay, so with the horizontal only it is making theta, here it becomes theta, right? So this is a component of what? U cos theta, and this is the component of what? U sin theta. Okay, now let us solve the momentum in both the directions. One is x-axis, another one is y-axis. First along x-axis supposed to be take. Okay, along x-axis let us see. So delta p x, p final minus p initial. So just m into velocity only. X-axis here you can see after rebounding it going like this, means x-axis means this is direction we get. So this is negative direction, negative x-axis. So that's what you take just to simply minus. So minus mu cos theta I cap minus initial this one. This is along right side. So right side x-axis, positive x-axis. Simply you can take mu cos theta I cap. So finally you get minus 2 mu cos theta I cap. Okay, so minus came again in the answer. So that explains actually its direction of a change in momentum. Okay, so direction of change in momentum is away from the wall, right? This is the explanation for along x-axis. And next along y-axis. So delta p y equals to p final minus p initial, right? P final is here downward. Okay na, downward I take as minus simply. So because upward we are taking positive, just I told you. Okay, so minus mu sin theta minus, this minus is from here. Next here initial also downward only. So this is downward. Again we need to take as minus. So here minus mu sin theta. Actually minus into minus plus. So this answer could be 0, which means in this case there is no change in momentum along the wall. That is, wall means y-axis only na. So along the wall there is no change in momentum. But change in momentum takes place in which direction? Perpendicular to wall. Okay na? So this is the scenario we get. Next, if you consider the angle, here it is 90 minus theta simply. Okay, but if the angle you consider with the wall theta, this become how much? 90 minus theta. So that is, we can understand from the concept. You can see here in the same diagram, if you take the angle with this direction is theta, then this become how much? 90 minus theta. Okay, so same scenario, everything, only angle is changing. With the wall I am taking as theta. Okay, so then here cos becomes sine, here sine become cos function. So that's what we can take, whatever the momentum change along x-axis come as cos theta, no? In this case what must come? Cos of 90 minus theta becomes sin theta. Okay, so that's what we can write here. Delta px equal to minus 2 mu cos 90 minus theta, which explains minus 2 mu sin theta. But along y direction same only, there is no change. Y direction momentum always come 0. Okay, but here comes function, actually here sin came na. Here in this case what comes? Cos comes. So mu cos theta minus mu cos theta plus mu cos theta will come in this situation. Again it cancel out to be 0. Okay, so there is no change in momentum parallel to wall. This is, you need to remember in the coming sessions, coming lessons also, it is very essential. Okay na? Change in momentum takes place only perpendicular to the wall, not parallel to the wall. Okay, so these are the some most repeated part of a change in momentum concepts. Okay na? Now let us move on to next slide. Here is one question. Okay, let us see that question. A 100-gram iron ball having a velocity 10 meter per second collides with the wall at an angle 30 degrees. So they said that here with wall 30 degrees only. So just now I told you in the last slide, with wall there is a chance, or with normal also there is a chance. Okay na? So now we can take at an angle 30 degree with the wall and rebounds at the same angle. See, here it is 30. So then it rebounds with the 30 degrees only. Okay na? Next, if the period of contact between the ball and wall is 0.1 second, then force experienced by the wall, how much? Generally, according to Newton's second law, F is directly proportional to dp by dt. Constant will be taken as 1. So F equals to dp by dt we will write. So that is change in momentum by time. Okay na? So now change in momentum, just now we have seen in the last slide. So whenever it is making angle theta with the wall, the function comes sine, but 30 degrees we need to take. With the normal line, how much angle it makes? 60 degrees. So when normal line we can take, then cos function will come. Just we have seen in the last slide. So that is 2 mv cos 60. Here minus they did not take because only magnitude they are asking, so we can find, right? So 2 mv cos 60 by 0.1 because time of contact 0.1. Okay, mass is taken as 100 grams, actually 100 grams. So we need to convert it into kg. So that is 100 into 10 power minus 3 kg, which is corresponding equal to 0.1 kg. Okay, so here 2 mass velocity cos 60 1 by 2 by 0.1. So 0.1 0.1 cancel, 2 cancel, and 10 newtons of force will become. So our answer is 10 newtons experienced by the wall in this situation. Okay na? So how we have a chance to be convert the angle If they gave the angle with wall, then also no problem. You can convert, because here it is become 90 degrees now. This is 30 means this is 60. And you just, I have given the proof for this one. Whenever it is making an angle 60 with the normal line, momentum change will be takes place given by 2mu cos theta or 2mv cos theta. Okay. So this is the way we can solve the question based on change in momentum condition. Next, the momentum time graph of a particle is given below and calculate the FA by FB. So here they are asking to find a ratio of FA by FB. So generally FA by FB, how to get from the graph of momentum and time. So let us see. Momentum and time is there. If I draw a graph like a straight line, suppose if I take a theta, this is okay na. So tan theta generally slope explains, okay na. So tan theta corresponding to, suppose here it is opposite side and adjacent side. This value involves a dp, means change in momentum. This value involves a dt, change in time. So it explains a dp by dt, which means dp by dt is according to Newton's second law, what we can write force. So this is force, means slope of the line equals to force. This is very essential. Okay na? So here also we can see with the time axis only we need to find slope. First one is making how much angle? 30 degrees. And second one from here how much angle it can make? 60, because 60 plus 30, 90. So then FA by FB tan 30 and FB is how much? Tan 60. 1 by root 3 by root 3. So root 3 into root 3, 3 will become. So that's what answer will be 1:3. It will come. So answer we can have second option. So this is the way we can find out when they gave graph based questions, we depend like slope or area, how it is related for asked quantity to find. Okay na? So here asked quantity is a force. Force depends on momentum and time definitely, but dp by dt equal to force. So definitely we can take slope of dp by dt explains force. Okay. So let us move on to next. Here two bodies of masses 6 kg and 9 kg are said to have equal momentum. So that is both having equal momentum. Okay na? So next, while in motion, if they are in motion, their momentum are same. So then ratio of their velocity is how much? So simply you can say take here one particle and here another particle. Okay, the momentum of both the particles are given same only. So that is P equals to constant. So simply we can take P1 by P2 equals to M1 V1 by M2 V2. But they gave P1 equal to P2 equal to P. Then it is out to be cancelled, it comes 1. Okay na? And mass of 1 is 6 kg, mass of 2 is 9. So 3 2s are and 3 3s are. So shifting on this one, 3 by 2 will come. So that is V1 by V2 equals to 3 by 2. So here the option is 4th. Okay. So if the momentum is same, generally we can say momentum is same in this case. V1 by V2 equals to what? We can get a inverse ratio of the masses. Okay na? This is very important point. Next after this one, let us see one more question here. Momentum of a particle is given 5t square I cap plus 10t j cap. It is just depends on coordinate system. Then find the magnitude and direction of the force acting on the particle at t equals to 1 second. Since it is given I plus j, okay na? So what we can explain or what we can imagine, the momentum of the particle is along xy plane. Okay na? It is present in between xy plane. So now according to Newton's second law, F equals to dp by dt. So which means we can just based on the differentiation form. Okay, differentiation form we have. So differentiation form questions we need to solve here. Okay, so first dp by dt is a very small change in momentum corresponding to very small change in time. So on giving equation we need to do differentiate with respect to time because given function also depends on time. So then 5t square I cap, 5t square when you do differentiation 2 comes in back, front will be multiplied with 5 and power 2 minus 1 which is, let me explain here, only 5t square. So 2 come and multiply with 5 t power 2 minus 1. Okay, so this is 10t will come. So that is only we have written here 10t I cap, and here 10 into t, t will be cancelled out, so 10 only left. And they have asked what time t equals to 1 second. So here time equals to 1 second. So we just substitute 1 second in the place of time. So here it is comes 10 I cap plus 10 j cap. So magnitude of a vector always a square plus b square if a vector is at plus bt or ai cap plus bj cap. Okay, so here 10 I cap plus 10 j cap is there. So vector magnitude will be taken as root over 10 square plus 10 square. Okay na? So just now I told you at plus bt, that is not correct. At I cap plus bt square j cap. Okay, then its magnitude will be at whole square plus bt square whole square. Okay, under root over. Now here magnitude we get a 10 root 2. Okay na? On simplifying, tan theta equals to, suppose here it is angle theta makes, okay na, with x axis. So here two components we have. So let us see, one component of force is along x axis, one component of force is along y axis. To find out the force, so you can consider your graph beta. So this is the force in some direction, it is making some angle theta, here 10 I cap, here 10 j cap, right? So tan theta is y direction, means opposite by adjacent side. Opposite is what? Y direction, and adjacent side is x direction. Okay, only force graph it is. Actually force components we have taken along x and y axis. So in such case f by fx we write 10 by 10 1. So theta equals to 45. So what is the magnitude we got? 10 root 2 and theta equals to 45. So this is answer will come actually whatever they have asked. So magnitude is 10 root 2 newtons and theta angle will be 45 degrees. Okay na? So let us move into next slide. A batsman hits 150 grams of ball moving horizontally. So here one ball whose mass is 150 grams moving horizontally with 20 meter per second. Okay, and back to bowler. So suppose if you can take, imagine I am drawing rough diagram. Okay na? After hitting with the ball go back with a speed of 12 meter per second. If contact of cricket ball lasts for 1 by 25 seconds, which is time equals to 1 by 25 seconds with the bat, then the average force that the batsman exerts. Okay, so bat exert with what force on the ball? So generally we can take according to Newton's second law, F equals to dp by dt, where dt is given already 1 by 25 seconds. So dp by 1 by 25, which is 25 into p final minus p initial. So 25 into p final mass. So final one is left side. So suppose we can take right side is positive and left side is what we can take negative. So it is left side, so I am taking minus 12 minus, here right side only, so m into 20, simply we can take. This is minus, this is minus. So definitely we can take minus of minus plus, this is minus, this is minus. So we get total answer is minus, means added only we can get. So here 12 and 20 32 m will come. Okay, so that is F equals to minus 25 into 32 m. So minus 25 32 into 150 grams it is. So we can take it as 1000 because 1 by 1000 1 gram equal to kg, 1 by 1000 kg. 1 gram equals to 1 by 1000 kg. So I just write here 1 by 1000. Here comes 0, cancel. Okay, na? This comes out to be 25 fours, right? Here 4 eights. So finally 120 newtons. This much force will be exerted by the bat. In which direction exert? Left side. So that's what here minus came. Okay, na? So minus came in the answer means it explains the direction in which it is acting. Okay. So now this is what the answer, and the way of procedure we can solve is change in momentum first it is involved, then by time explains about force. Okay, na? So next a very flexible chain of length L and whose mass is m is vertically suspended with its lower end just touches the table. Like this situation. So here it is the table, suppose. Okay. And if it is released so that each link strikes the table and comes to rest. Okay. Like these are the links here. 1, 2, 3, like links are there. When we release, no, the link touches the table and comes to rest on the table here. It is just like a grouping on the table, collectively grouping on the table. Then what force the chain will exert on the table at the moment y part of length falls on the table. Total length is L, but the length of chain falls on the table is y part. Okay. So here you definitely know about one point, that is linear mass density. Concept of linear mass density. Okay. So that is actually explains about lambda equals to mass by length. So total mass of the given linear distribution by total its length. Actually it is lengthwise distributed. Suppose if you take a disk, area wise mass distribution takes place. Then mass by area we should call that is. Next, mass by volume if you take a spherical distribution. So then you can take the density will be mass by volume, that is regular density, you aware about that. But in this standard we need to know about two more types of densities, that is linear mass density, next to surface mass density or areal mass density we can call. Okay. So that is here mass by length. So y part of the chain falls on the table. Okay, na? Then how much mass of the chain falls on the table we need to find out. Okay. So that is, suppose you can just understand, if this is the total length of the chain, okay, this is total length of chain and if its mass is total mass m, but y part, this is y part and its mass I have taken as m prime. Okay. So what can I write from this formula? M prime by y equals to m by L. So m prime equal to my by L. This is the mass of chain falls on the table. Okay. So now let us see question in detail first. Whenever each link strike the table with some velocity definitely. Okay, na? So before touching the table it is having some velocity. After touching with the table it comes to rest as it is given in the question. Comes to rest. So velocity changing, mass also changing actually. So mass and velocity both are changing here. Okay, na? Means mass collectively increasing on the table. For each link mass is constant you can take. Okay, na? For each link whenever its velocity is going to coming to stop, momentum also change. Which means due to change in the velocity, momentum change. To happen this some time takes place. Next, collectively grouping some chain part on the table, means mass of the chain increasing on the table. So there is two reasons which we can where in which directions or in which ways it can be experience some force. That is, one force due to weight, another force due to change in momentum. That is the net force experienced by the table in this question. So F net can be taken as force due to weight, force due to change in momentum, and simply force due to weight is explained as mg. Okay, but here m prime g only we have to take. Why? Because not all the chain is falling on the table, or the situation they said the moment y part of the length okay falls on the table. So that's what y part of mass only exert weight force. So y part of mass, how much we got? My by L. So simply we can write down myg by L. So this is first part finished. And second part, change in momentum. So simply second law explains dp by dt, change in momentum by time. Okay. So now here I am writing velocity into dm by dt. In the last class I discussed second law. If the mass variable, then velocity constant. If velocity variable, then mass constant, most of the scenario. Here mass of each link is variable, means each link constant, but the mass is continuously coming and collecting on the table. Na? So that's what we need to consider variable mass. But from same height, suppose the each link coming from this height falls on the table. So whenever it is falls from certain height, what velocity with which it is going to strike, from the concept of what v square minus u square equal to 2as, or downward falling, so 2gy. From which height it is falling, supposed to be take y height if it is falling. So initial velocity 0, so v square, so velocity must be taken as 2gy root over. So now here it can be taken as myg by L, v can be taken as root 2gy, mass equal to y part falling, means here total mass we don't take, only y part mass falling, so y part mass only we will take. Then y part mass instead of lambda, how much answer we got here? M prime by y equal to m by L, means lambda equal to m by L. So m prime equal to my by L. This mass only we can substitute in this place. So differentiation m into y by L. Here this mass, total mass of the chain, that won't be changed. Total length won't be changed. So myg by L plus root 2gy. Here m by L would be constant only. So dy by dt. So from y height it is falling, so definitely it achieves some velocity v, and that velocity already we find v equal to root 2gy. So simply we can write g by L plus root 2gy, here m by L root 2gy, root x into root x only. So simply we can write 2gy. So that is on simplifying mgy by L, m into 2gy by L. So totally 3mgy by L. This is the amount of force, okay, which can be experienced by the table, right? Here two forces are there. One is due to change in momentum, another one is due to change in the weight. Okay, na? So final answer how much, sir? F equals to 3mgy by L. This is answer. Okay. So here linear mass density, one new quantity will be introduced. Next equations of motion we use, and Newton's second law we use, weight force we use. So somehow many concepts involved in the question to get the answer. Very neatly you need to be observe the question. Okay, na? So then only you will collect this concept, right? So once again, when certain chain of length it is just touches the table, then on dropping this one, some part is going to be fall on the table and collectively grouping on the table. Okay, so why part of length fall on the table? What force it will be felt by the table, they are asking here, or what force it exert on the table. The same concept only we can take. The force exerted by the chain will be of two types. One is due to weight, another one is due to change in momentum. So that is the sum here, but total chain is not falling on the table, means that up to some time only they are asking. So what time, up to what length of chain falling on the table? Y part. So to get the Y part chain mass, we need to take a m prime. So here lambda explains mass by length here. Okay, na? So mass by length equal to m prime by y. So the part of chain mass by the part of chain length. So m prime equal to my by L. So here we can substitute m prime g plus dp by dt, change in momentum. So p equal to m into v, m will be change, no, variable, na? So m prime will be taken from the same equation only, and just simplifying to get this answer. Okay, right. Next, a body of mass 10 kg is being acted upon by a force 3t square and an opposing force constant of 32 newtons. Okay, so here suppose force acting right side 3t square F1, opposing force constant 32 newtons. So then net force acting on the body 3t square minus 32 newtons. This is the equation we need to generate. Okay, na? Then initial speed 10 meter per second, u equal to 10 meter per second. Find the velocity of the body after t equals to 5 seconds. Okay, so from 0 to 5 we need to estimate here. So we got F equation, and from the second law it is written ma 3t square minus 32, and a can be written as dv by dt. Okay, this is 3t square minus 32. So simply here dv and m only you can keep, and here 3t square minus 32 into dt. So v function, here time function. So we need to choose the limits 0 to 5 seconds, and here initial speed is given for 10 meter per second. Okay, so initial 10 meter per second and final speed they are asking to find. So dv integration will be v only. So we can write m into v minus 10, upper limit minus lower limit, okay, equals to integration 3t square will be 3t power 3 by 3 minus 32t, here 0 to 5 seconds. Here 3 cancel. Okay, here mv minus 10, m value how much? 10. 10v minus 100 we can write. Okay, so that is 10v minus 100. Here t cube means beta 5 cube you can write. 5 cube, 5 is a 25, 25 is a 125. 125 minus, okay, 32 into 5, right? Here 10v equals to 125 plus 100, because it is shifting right side. So minus 32 into 5, 160 it is. 5 2 is a 10. So 5 3 is a 15. So right. Okay, na? 160. Here it is 225 minus 160. Okay, so here it is 10v. So we got 225 minus 160, here 40 plus 20, 65. So v equal to 6.5 meter per second. This is the speed acquired by the body. Okay, na? Actually speed decreasing. Why speed decreasing? Means here force is opposing, na? So that's what speed is decreasing. No problem. The answer is this much. Okay na? So this is the way we need to solve the question. Okay, let us move on to next slide. A disc of mass 0.1 kg is kept floating horizontally in mid-air by firing bullets, okay, by firing bullets of mass 0.05 kg, okay. Each of the bullet 0.05 kg, here it is firing with the gun onto the plate. The rate of bullets 10 per second, okay na, means at which rate the bullets are fired, 10 per second, 10 bullets per second, okay. If the bullets rebound with the same speed, means after hitting the plate they come out with the same speed with which these are fired. So what velocity the bullets are getting fired. So let us take the concept first. It is a disc, okay na, right. This disc is kept floating in the mid-air. Generally, if we do a magic and make a float, that is not possible, okay na. So how we can able to float in the mid-air? By striking with the bullets, okay. It is fired with the bullets here. Now after striking, the bullet coming back, suppose it is go and hit the plate with the speed v and come down with the same speed v, okay. So change in momentum, how much it will takes place, we need to find out, okay na. So downward I take as minus and upward I take as plus, okay na. So now each bullet mass I am taking as m. So change in momentum can be taken as p final minus p initial, downward na, so minus mv minus mv, upward plus only, so finally minus 2 mv downward direction, okay, on the bullet. But this change in momentum takes place on the disc also, okay. So on the disc what happened, it is upward, this is on the bullet downward direction, okay na. And opposite to that one, on the disc change in momentum takes place with the same rate only, okay. So change in momentum on the disc is exactly opposite to change in momentum on the bullet, okay. So now we can write down minus into minus, we can take as 2 mv change in momentum for disc, okay na. So now coming to the point, force. What force experienced by the disc, because this much change in momentum in what imparting for the disc by the bullets firing. So then it can provide what force onto the disc. So according to second law, delta pd by delta t or dt, okay. So we can take as dt. So now it is 2 mv by t, for fraction of second I take, okay. So now here 1 by t we can take it as also as a frequency. Suppose same concept we can deliver here from here to here, and I have derived this equation for one bullet beta, but here not one bullet is striking, n number of bullets hitting suppose. So I can take it is for n only, one bullet this much, n bullets n into this much. And same could be taken place on the disc also. Here also n comes, this n by t can be written as frequency, number of bullets per second, that is what at 10, okay. So that is f equals to 2 mv small n. You must be remember this small n, how we can take, okay na. So small n can be written as number of bullets per second, and it could be changed in some books also, capital N give here, small n give here, but meaning same only. Capital N is number of bullets per second in some books given, small n is number of bullets per second I am explaining, okay na, don't get confused, okay. Small n means what, number of bullets per second. So then this force can be felt by the disc, in which direction it felt, upward. So weight of the disc is in which direction, downward. So disc felt force due to change in momentum upward and weight force downward. If it is both are balanced, then only the disk will be float in the air. So that's what this is. A momentum change force and weight force can be taken as capital mg and 1, and this is 2. 1 equals to 2 because it is kept floating in the air. So we can write 2 mnv equals to mg. They are asking for the speed. So capital mg by 2 mn. So capital M is disk mass. Disk mass is 0.1. I am taking G value 10. 2 into mass of bullet 0.05 into kg only, and here 10. Okay na? So now this decimal cancel, 0 cancel, and 0 cancel, 1 decimal comes forward. Okay na? And here 0.5, 2 cancel only. So we can take it is 1 meter per second. With what velocity the each bullet is fired means 1 meter per second. Okay. So this is the way we need to solve the question, how a momentum change involves and how it is going to be impart the force, and that force is responsible for the balancing weight force. Okay. Let us move on to next slide. Next topic actually impulse. Okay na? What is called impulse here? The change in momentum suffered by a system due to action of force for an infinitesimally small amount of time, very short amount of time, okay, is called impulse, and given by the force to the system actually, whatever the force been acting or just exerted by the external source. Okay. So what actually explains impulse means very short interval of time, if any force acting on the system, then change in momentum takes place. This phenomena is called actually impulse. Okay. So here is the situation. V initial, Vi is there, and momentum we can take P initial right side, and final velocity V final, final momentum mv final. But the ball final velocity and final momentum, how it was got means, for the fraction of second he was given some force on the ball, means he was kicking the ball. Kicking the ball means very fraction of seconds it is in contact. So in such a time, what kind of change in momentum takes place is called impulse. That is actually F into dt. This is P final minus P initial, and it is actually called delta P. This is also called impulse momentum theorem. Okay na? Or principle of impulse momentum we can also call, right? Generally J equal to F into T we will write. J is called impulse. Okay. So that is F into T we can write, and you should understand here, if time of contact is small, the magnitude of force will be large, and vice versa is also possible. Okay na? So now coming to the part, F into T means F equal to dP by dt from the second law. F into dt equals to, we can write dP, that is change in momentum. So we got change in momentum. That's it. So this is also called impulse momentum principle or theorem. Okay. Next, and it is also very essential, impulse applied to an object in the given time interval is the area under ft graph, force and time graph. Okay na? So if force and it is a time actually, okay. So the force acting versus time graph, if we got this curve, and area under this curve we can get a impulse. Why? Because if we can take a small elemental one, and this could be taken as a dt function, okay na, and this could be taken as f naught, area of the element how much beta? So f naught into dt, which is height into thickness only na, rectangular form only na, f naught into dt. F naught is f only, force only, dt means time, f into time is what? dp, dp is what? J, like impulse. So we need to find from here to here, so this is to be integrated from the limits 0 to given time. So that explains area under f and t graph gives you impulse. Okay na? So let us move on to the next one. Force acting for short interval of time is called impulsive force. Okay, na? Which means whatever the force is being acted by the object or acting by the some external agent for short interval of time is called impulsive force, right? Now, impulsive force can be acting for short duration and significant change in the momentum. There is a significant change can be created. Okay, na? We will see some exemplar points also how it is going to be happen. Okay, let us move on to next slide. Applications here, what happens? A cricket player lowers his hands while catching a cricket ball. Why, sir? Why he should lower the ball? Hands of him is hands should be lower to catch the ball means. So let us see. When he was suddenly struck the ball, okay, ball was coming from the bat hit by the person. So it was moving actually. Suddenly it was struck by hands. So momentum changes drastically. So it was in motion, and when it is coming to contact, like suppose it is going to be catch, like immediately catch, and it is not a given way back, and it is just catch. Okay, so suddenly change in the momentum takes place, which means you can see till here it is in motion. After striking comes to rest. So very fraction of less fraction of time. Okay, very small amount of time it takes place to change in momentum. So when short time is there, then impact of force will be more. So to reduce this impact, we need to allow the ball to catch and to move our hands in the same direction of ball. So you might see in the cricket keeper, he catches the ball like this only. Okay, na? By most of the fielders it won't be, they just catch suddenly only. So but whenever they catch suddenly, they get hurt in the palms. So you need to know that is because of only more impulsive force, because fraction of time, very small time it will takes to change in momentum. Next, an athlete is advised to comes to stop slowly. Okay, yesterday I discussed due to inertia of motion also is one of the concept, and whenever you want to stop immediately is motion, then change in momentum drastically takes place. Okay, na, he gets hurt definitely. Okay, internal hurts will be there definitely. So why? Because the change in momentum allowing need to be taken place, means there's more time of contact should be given, then get hurting is very less. So when he was reaching the target, he asked to slowly stop down. Okay, na, means just he slow down slowly. So immediately he gets stopped in a fraction of time, very small. So then impact force will be more. So that is the reason here. Next, China wares and glass wares are wrapped in the paper as straw pieces. If you might seen in the parcel boxes, and if any fragile substances are there, so they need to be packed in the straws or any kind of such air bubble packages. Okay, na? Why they need to package in such a way means they get hurt immediately because of for fraction of seconds of time of contact of force. And if they drop the package, they suddenly come to contact to the ground only, and from whenever it is falling from certain height, it is gain some velocity. So momentum will be there, and dropping on the floor suddenly changes momentum into zero. But it does not take more time, very small time. So it get hurted. That impact will be reach the direct objects. Okay, so that objects are going to be fragile actually, so they will be broke. Next, the vehicles like scooter, car, bus, truck, etc. are provided with shock absorbers. Okay, it is very important. When a vehicle is riding by the person and wheels are going to hurt by the obstacles on the road, okay, na? That hurting will not transfer directly onto the person because of shock absorbers. Once it gets hurt by the road, by the tire send the that same shock to the absorbers. So then it allows for some suspension, means time lag. When time lag is there, the impact will be reach the person less. If no shock absorbers fixed for the vehicles, then direct impact to the person only transfers. Okay, so this is what a time of contact should be increased to minimize the impact force. That is what they provide with the shock absorbers. Same situation for the train also. Bogies of or coaches of a train are provided with the buffers. Connection of the coaches, in between them buffers are provided. If a loco pilot suddenly brake applies, then each coach will be have a certain momentum. Okay, na? They come to stop immediately, no? So then they can feel some jerk. So that avoid that large jerk, na? So they will provide with buffers like a shock absorbers work only. Okay, so get the more time of contact to lower the impact, right? So this is what somehow concept related points based on impulse. Now let us see one question. A force F acting on a particle of mass m indicated by the force versus time graph here. Okay. Next, the change in momentum of the particle over the time interval 8 seconds, which means in a given complete time interval. So for 2 seconds, actually at 0 seconds 0 force, 2 seconds it is maximum 6 newtons of force. Again here it is going to be negative way, means direction of force changed, then again positive way, here direction of force 3 newtons. So force versus time, na? So force versus time means just now we discussed. If you find the area under the force versus time, what do we get? Impulse. Impulse is nothing but what generally? Change in momentum. So here change in momentum equals to impulse. A change in momentum or impulse equal to area under the FT graph. So simply you need to find this entire area. Okay, it is in a triangular manner, half into base into height. Half base is 2. So base is 2. Height is 6. Okay, next this is below the mean position, otherwise it is minus. Okay, na? So here change in momentum vector only, na? So we need to take that value. If answer we are getting is scalar, no bother about this is to be taken minus. We are getting vector quantity, so definitely below the mean position value is to be taken as minus. Okay, so it is a length into breadth. Breadth is 3, length is 4 minus 2, 2. 2 into 3. Okay, plus again it is above the mean position. This comes out to be 4 and this comes out to be 3. 4 into 3. Okay, so now here 2 3 is a 6, 4 3 is a 12. It comes 6 only. Here 2 cancel, 6. 6 plus 6, 12. 12 Newton seconds. I have already told you momentum units. Change in momentum also same. Okay, na? So this is what regarding one question, how we can solve based on the graph model. Let us move on to next part. Conservation of linear momentum. Okay, conservation of linear momentum means how we can able to define and what is the concept. If external force acting on the system add up to 0, which is if there is no external force acting on the system, okay, then momentum, linear momentum of the system remains constant, right? So that is the concept we can take. This is known as the principle of conservation of linear momentum, LCLM generally we can call. Okay, F net, that is F external on the system, dp system by dt. F external 0 means P initial equal to P final. So just you can solve reverse concept. Okay, na? So if I take momentum is constant, what I am taking? Momentum is constant and I need to differentiate here dp by dt. Constant differentiation 0. dp by dt means what? F. Force 0. Okay. Force acting on the system is 0, which explains what? Momentum of the system remain constant. Actually momentum not dp. dp is constant. Okay. Sorry, dp is 0 only. P constant. Right? dp equal to 0. That is P final minus P initial equal to 0. That is P final equals to what, sir? P initial. So that is only we have got here. P final equal to P initial. Here you can see, here one truck containing 3 masses. It is moving with some momentum mvcm, com, velocity of center of mass. Okay, na? In coming chapters you learn center of mass means. Okay. So it moves with some velocity. So that is total center of mass we have taken. And no external force is acting on the truck and masses also. Then after some time also with the same momentum only they need to travel. So when there is an external force acting on the truck, then there is a definitely change in momentum takes place. It is valid up to if external force acting on the system is 0, then momentum of the system will remain constant. Okay na? So that is what the conservation of linear momentum. Next, external 0 P system equal to P final system equal to P initial system. And if we apply along the different directions, we might think any directionals it can be applied. No. If you are applying in the question x-axis, then x-axis momentums only equal if f external is 0. And don't make equal initially initial momentum along x-axis equal to final momentum along y-axis. Why? Because LCLM is depends on direction. Okay na? You need to conserve separately along x-axis separate, along y-axis separate, along z-axis separate. The same explanation is here. External force, sum of external force along x-axis 0, then momentum is conserved along x-axis, that is momentum initially equal to final along x-axis. The same with y and z-axis. Okay, here important, if any direction change concepts are coming in the question, you need to apply separately for each direction. Okay na? So next, here one question, a body of mass 1000 kg is horizontally moving with a velocity 50 meter per second, okay, and a mass of 250 kg is added suddenly. Find the final velocity. How it is added they have not given, just added suddenly, that's it. It is going with some velocity v initial case 1000 kg, and on the 1000 kg 250 suddenly added, okay, and it will go in different velocity, go with different velocity. So what is that final velocity they are asking? So here added to that one and does not exert any force, suppose, then only momentum of the system conserve, otherwise momentum disturbs. Okay na? So here we can take, adding to the concept is taken as internal concept, means externally force apply on first one they are not placing, just they are placed suddenly and there is no change in momentum, there is no external force acting on the system. So that's what final momentum equal to initial momentum takes place. Now let us see momentum conservation, final momentum equal to initial momentum, that is initially it is how much speed of 50 and having 1000. So finally it becomes 1000 plus 250 because both the masses are there. So here V2 equals to, on simplifying, we get 40 meter per second. Okay. So this is the way we can solve the question. Next, our answer we got here 40 in the options. Okay na? Next let us see, a gun of mass 10 kg and fires 4 bullets per second. The mass of each bullet is 20 grams and velocity of the bullet when it leaves the gun is 300 meter per second. Then average force per second required to hold the gun while firing. Actually here conservation of linear momentum means some applications for the conservation of momentum we can discuss, that is when it is fired a bullet from the gun. So when bullet is leaving from the barrel, okay na, so then we can see it leaves some momentum onto the gun. So gun should be recoil. So whenever it is going forward with some momentum, recoil momentum will be there for the gun. So then we feel some momentum is exerting, means momentum change for a time is called force. That force we feel on our shoulder when a person is firing a gun and keeping against to the shoulder. Okay, so that force is called recoiling force. Here rate of change of momentum of the bullet in forward direction, okay, is equal to force required to hold the gun. That's it. Means whatever the force can be exerted on the bullet, that much force only we need to require to hold the gun, and that force because of what? Change in momentum of the bullets. So here just now we told you and we discussed you where what is that? If it is hitting and come back 2 MNV we got, but here it is going outside, so only we can take MNV equal to F. N is number of bullets per second and M is mass of bullet 20 into 10 power minus 3 kg and velocity is 300. Okay, here 3 zeros could be cancelled. So 3 to the 6, 6 4 the 24 newtons. Okay, na? So final answer, to hold the gun, whatever the momentum change by the bullet and leaves the some force or exert some force on the gun. So we need to hold with the same force only. That force comes here 24 newtons. Right? Thank you. This is the part of the impulse.